Welcome to part 6 of our programming series about graphics programming. Today we are taking a look into texture mapping, or in other words, we want to display this image instead of the solid color we are rendering at the moment. Like the image name clock background already suggests, we are on our way towards building an analog clock, and this is the first step in doing so. As you can see, I created 2 new folders for resources and libraries. The resources folder has the clock background image in it, and the libraries folder contains a small header-only library to read in images. In order to render this image, we need to do 3 things. First, we need to load the image, so the pixel data and the dimensions. Then we need to create a texture object with the correct texture coordinate set. And the last step is then to use the shader and sample the texture and render the pixels into our frame buffer. To load an image, we start this off with creating a structure holding all the data. But before that, I again simplify things a little and create type defs for unsigned and signed integer values. And now, this is the void star is for our data, the pixels, width and height of the image, and the number of channels. In our case, this will be 4, like RGBA. In our renderer, I now add a new member to hold the background image. So this is of type MTL texture. And now we will create and implement the load background function. Loading the background is again subdivided into 2 steps. First is to create the image structure and read in the raw image data. And the second is to create a texture object, which I'm doing first here. So for that we need a texture descriptor, give it the width and the height of the image, as well as the pixel format, which happens to be the same as our color attachment. With the texture descriptor in place, we can now go ahead and create a new MTL texture object. And the next step is then to copy over the raw data from our image structure into the MTL texture. So here we give it the width by 4 is the bytes per row, the raw data is the bytes, mid level is 0, and the region is the size of the full image. Since our background image is a little bigger than the current window size, I'm now replacing all the hard-coded 500 values with 600. In the later stage, we can also make this configurable so that we don't have any magic numbers in here anymore. The load background function is still missing a means to read in the PNG image from our resource folder. So I'm now creating a new set of files for platform services, because I figure we will need loading images more often and maybe in an even platform independent manner. So here I'm creating a small API for loading images from a given path. And the implementation will use the SDB image library, which you can find on GitHub, or is also included in my GitHub project here. And well, it's pretty straightforward. We create a new structure for our image on the heap, and then we will use SDB iLoad to get the raw data from the PNG. The load function not only gives back the raw pixels, but also fills in our structure with the width, height, and number of channels. Now we can include the API into our renderer and just call the function to get all the data, and the rest of the load background function is already finished. Before continuing, I would like to pause here for a second and introduce the guy who originally invented texture mapping in 1974. The guy's name is Ed Catmul, and yeah, here you can read it in his thesis. He already mentioned it gives a method for putting textures, drawings, and photos onto surfaces. Apart from his major contributions to computer graphics, he's also well known for having worked at Lucasfilm, being a co-founder of Pixar, and a president of the Disney Animation Studios. The idea of texture mapping is to map the points of our geometry to an input image. So all our input points A, B, C, and D need to map to the texture coordinate system depicted here, and that will give us in the end specific texture coordinates corresponding to our input geometry. In the last episode, I already added the member for UV or texture coordinates to our vertex input structure. So now we can fill these in. And for our point A, the texture coordinate is 0, 1. So 0 on the x and 1 on the y-axis. B is 1, 1, and so on and so forth, as depicted in the small diagram I showed a couple of seconds earlier. The last missing piece on the CPU side of our little example here is to send in the texture to our fragment shader. So this is what we are doing here. And now we can check if everything works. Of course, there are still errors, so I used a small function to create a 2-element vector, and I need to implement this here in our typesetter file briefly. The second error indicates that we have not included the CPP file into our main, which is necessary for our Unity build. And now, once we do this, the undefined symbol error should be gone, and we can continue with the shader. While building the project, I saw that there's a small thing happening in our build script. So now we are counting also the lines of code in our header-only library, and I want to not do this. So that's why I will create a clock-ignore file, specify the libs folder here, and then we should only see the lines of code we have written ourselves. The remaining part now is to adapt our shader to take in the texture 2D, which we have specified in our rendering function. So this is what we are doing here. Then we need a so-called texture sampler, which picks out individual pixels from our input texture. In this case, we are using linear filters, both for magnification and minification. And the last piece is to pass through our texture coordinates from the vertex shader to the fragment shader, which we are not doing at this point. So first we need to add the texture coordinates to our vertex output, and then we basically need to copy over the input texture coordinates to the output ones, and in between vertex and fragment shader they will be interpolated so that we get a smooth range from 0 to 1. And with fixing the last remaining small typo here, we will hopefully now see our background image rendered into our window, which is the case. So success, and yeah, thanks for watching. Until next time.